Welcome everyone. In this video lecture, we will learn what is Chebychev's inequality, what is the use of this inequality, and how this inequality can be applied on the numerical problems. So let's start from the statement. If x is a random variable with mean mu and variance sigma square, then for any positive number k, we have probability mod x minus mu less than k sigma is greater than or equal to 1 minus 1 upon k square. Or probability mod x minus mu is greater than or equal to k sigma is less than or equal to 1 upon k square. Let's see what is the use of this inequality. Suppose this is a standard normal curve. For standard normal curve, mean is always 0. So this probability is the probability that x lies between minus k sigma and plus k sigma. Okay, so if we take suppose k equal to 2, so probability that x lies between minus 2 sigma and plus 2 sigma will be greater than or equal to 1 minus 1 upon 2 square. That is 0.75. That means the area lying between minus 2 sigma and plus 2 sigma, or the value of z, because in a standard normal curve x is converted into z. So z lies between minus 2 sigma and plus 2 sigma. This probability or the area between minus 2 sigma and plus 2 sigma is greater than or equal to 0.75. Or we can say that area outside these two limits is less than 0.25. Obviously, when this value is greater than 75%, these two areas, the total area under these tails will be less than 25%. So we can approximate the area between different limits using this inequality. So let's see the proof of this inequality. In this proof, we suppose that x is a random variable and it is continuous. If x is discrete random variable, then the procedure will be same. So for continuous random variable, we know that sigma square is expected value of x minus ex whole square, where ex is expected value of x, which is nothing but mu, which is given in here, that x is a random variable with mean mu. So we replace ex by mu. So expected value of x minus mu whole square will be obtained by using probability density function for a continuous random variable. So we integrate from minus infinity to plus infinity the product of x minus mu whole square into fx dx. Now this integral limit, because these two variables mu minus k sigma and mu plus k sigma will definitely between minus infinity and plus infinity. So we can split this integral from minus infinity to plus infinity into three parts. One is from minus infinity to mu minus k sigma. Another is from mu minus k sigma to mu plus k sigma. And the third one is from mu plus k sigma to infinity. Now we can write that sigma square will be greater than or equal to sum of first and third. Why? We have omitted this integral because these integrals are positive numbers. So sum of three positive numbers will be greater than sum of, if we remove any one of them, so sum of that two numbers will be less, obviously. So we have omitted this middle one. So sigma square will be greater than or equal to first integral plus third integral. Now for this integral, first one, we have limits from minus infinity to mu minus k sigma. That means x is less than or equal to mu minus k sigma here. That is x minus mu is less than or equal to minus k sigma, or minus x minus mu is greater than or equal to minus k sigma. You can take the you can square both sides, so that we get mu x minus mu whole square is greater than or equal to k square sigma square. You can omit this term. And similarly for this integral also, we have x minus mu whole square is greater than or equal to k square sigma square, because here x is greater than or equal to mu minus k sigma. So for both we have x minus mu whole square is greater than or equal to k square sigma square. So these two sums will be greater than or equal to k square sigma square into, you replace this by k square sigma square and k square sigma square here. So k square sigma square will be common. We are left with these two expressions. So ultimately sigma square will be greater than or equal to this expression. Now see this integral. This is what? This is the probability that x is less than or equal to mu minus k sigma. And this is the probability that x is greater than or equal to mu plus k sigma. So we replace them by corresponding probabilities. This can be written as probability x minus mu less than or equal to minus k sigma, and this can be written as x minus mu greater than or equal to k sigma. So probability, when you multiply it with negative sign, you will get this expression. This will remain as it is. So these two, combining these two, we can write probability mod x minus mu is greater than or equal to k sigma for these two expressions. So when you solve this, you will get probability x minus mu greater than or equal to k sigma is less than or equal to 1 upon k square. And for the second expression, that is this, we use this result, that probability x minus mu greater than k sigma and less than k sigma will be equal to 1, because total probability would be 1. So we multiplied this expression with negative sign and add 1 to both sides and replace this by this probability, so that we have this inequality and this inequality as desired. We can get another expression also in terms of variance. If we replace k sigma here by some constant c, then the value of sigma will be c by k. So we replace, value of k will be c upon sigma. So we replace k square by c square upon sigma square. So this inequality in terms of variance will be equal to this, and this inequality in terms of variance will be equal to this. You just simply replace k sigma by c and k by c upon sigma. Because these are useful in numerical problems, so we have converted them in these terms. For example, a symmetric die is thrown 600 times. Find the lower bound for the probability of getting 80 to 126s. One thing I want to tell you, that these inequalities are nothing but these are providing you the lower bounds and upper bounds on the probability. This is nothing but the upper bound on the probability, and this is the lower bound on the probability. So in numerical problems, you can also ask about upper bounds and lower bounds. You can use these inequalities as well. So symmetric die is thrown 600 times. We have to find the lower bound for the probability of getting 80 to 126s. Means the probability of getting 80 to 126s at most कितनी होनी चाहिए? At most. Lower bound means at most. If we are asked upper bound, that means at least कितनी हो सकती है, right? So we are given n is equal to 600 and we take x as number of success. so that uh, we can use this inequality, because we have to found the lower bound. So this is a lower bound. So first of all, we find the bounds on x by simplifying this expression. You can see this is very simple, and here is the final expression. Now we find mean first of all. Because this is a binomial distribution, we have success or failure, and they are repeating in each and every trial. There are only two outcomes. So mean value of a random variable x is given by n into p. N is 600, p is probability of success, which is getting 6, which is 1 upon 6. So it is 100, and variance is equal to npq, so that the value of variance is 500 upon 6. We can substitute these values here, and the value of mu here. This is c is a random constant, so we have to see that to get this expression, what should be the value of c. So obviously c should be 20, so that we have 80 here and 120 here. So the answer is 0.79. Next problem is, an unbiased coin is tossed 100 times. Show that the probability that the number of heads will be between 30 and 70s is greater than 0.93. एक कॉइन को टॉस किया गया है 100 टाइम्स. हमें ये बताना है कि नंबर ऑफ हेड्स अगर 30 से 70 के बीच में मिलेंगे, इसकी प्रोबेबिलिटी 0.93 से ज्यादा होगी. मीन्स ये लोअर बाउंड है, हमें ये प्रूफ करना है. लोअर बाउंड ये आएगा इस एक्सप्रेशन के लिए, इस प्रोबेबिलिटी के लिए. सेम प्रोसीजर फॉलो करेंगे इसमें भी. म्यू इज n into p, 100 into 1 upon 2, because p is the probability of getting head, 1 upon 2, and pq is 25. अगेन वी फाइंड दिस एक्सप्रेशन, जैसे हमने पहले क्वेश्चन में फाइंड किया था, ये वाला. ये मैं डायरेक्टली यूज कर रही हूँ यहाँ पर. Now we compare this with this. So obviously the value of c will be 20. Putting c equal to 20 here and here, you will get the lower bound. And this will be equal to 0.93 when you solve it. I hope कि आपको lecture समझ में आया होगा. If you have any query, you can ask. And if you have understood my lecture, you can like and share it for more videos. Thank you very much.